Hi folks, how you doing? So, just a little twist on um, trig equations. We're dealing initially with double angle, so let's go for it and see where it takes us. So this looks like one that we've seen previously. So cos 2x minus cos x equals 0. What we did initially was we wanted to get rid of the sine 2x or the cos 2x, so we've got a cos 2x here. So what we need to do is we need to get rid of that. Or sorry, replace it. So that's what we want to do. And so here we go. That's our replacement because the only other trig part, it just involved, it's either going to be for us sin x or cos x. So it was cos x. So our replacement has to involve cos x only. So that's why our replacement out of the three, which you know, has to involve cos x only. And when I say cos x only, you know, I mean that's cos x only. It doesn't matter about the 2, it doesn't matter about the squaring, it doesn't matter about the take away 1 thing. That's cos x only. Right, that's a replacement. Everything else will stay in place. Okay, right. Oh, that looks fantastic. In previous examples, you would only end up with something like that there, and that means you could probably factor out a cos x and a cos x, but we can't because danger, stranger danger. We've got that there, a wee constant stuck on the end here. Right, so this is a bit of a nightmare, but it's not really. I'm just rearranging it here, putting an order of powers of cos squared x, cos x, that's relative to the power 1, and a number of n is 1. I'm rewriting cos squared x here as what it really is. Cos x all to the power 2. That's what it is. Right? And that's just to allow us to see that this is really a quadratic in disguise. And the reason I'm using the letter U is because it's my choice. The letter U is known as a substitution variable. Right, so I'm just going to go for it. So get rid of cos x. Anywhere with cos x, I'll put in the letter U. Okay? Trust me on this one. It's like me packing up my clothes in a suitcase. Right, so I'm going to take that. I don't like that bracket there. Don't you worry about that. I don't like that bracket. So, up 2u squared, take away u, take away 1 equals 0. Is that familiar to you? Hopefully. That is a quadratic equation. You should be familiar with that. Except you usually have an x in that there. So we can solve it hopefully. Hopefully by various methods. We could factorize it. Quadratic formula always works if there are solutions, or complete the square, which I've totally forgot about, haven't you? Right, okay, so how am I going to solve it? I like this one. I know how to factorise things, so I'm going to put in a 1 there. Do you see what I've done there? Put in a 1 for view. That's just in case you want to use quadratic formula as well. Because A is a thing in front of the square term, that would be 2. B, a thing in front of the singular U term with -1, and the constant term is -1 at the end next to equals. So I'm going to use factorising. So two things that multiply to give me 2u squared. Both must contain a u. I could have went for 8u and u over 4, or u over 8. No, u over 4. So those two things, I'm going for the simplest things here. Both of them multiply to give me 2u squared. Also, two things that multiply to give me 1. Forget about the sign here. Just 1 and 1. That looks good to me. Right. Oh, positive -1. So what I'm doing here is a wee check here. Positive 1 times u is positive 1u, and 2u times -1 is -2u. Add them together and I get, hopefully, the middle term. Right. So you need to go and sort out your factorising. But I think I'm going to pop a wee video for those who hate factorising. Or maybe you weren't exposed to it that much. That doesn't matter. So I've factorised it. I've got to there. Okay, so a bracket and bracket equals 0. That means one of them equals 0, or the other one is equal to 0. Okay, 2u plus 1 equals 0, or u minus 1 equals 0. Let's deal with one of them. Let's deal with the left-hand one. 2u plus 1 equals 0. Let's solve it. 2u plus 1 equals 0. 2u equals -1. Technically, add -1 to both sides. Then divide by 2. Get that there. But we're not solving for u. We use u as a substitute. Okay, because we know that u is really cos x. It's -1/2. Right, this is us. We're back in the trig world. Okay, cos x equals -1/2. So let's go all sine tan cos. Where is cosine negative? Sine and tangent, we've seen that before. Okay, 180 minus 180 plus. Remember at this point here, get rid of the negative because the quadrant check doesn't work with negative values here. So cos A equals 1/2. Where does cosine of an angle equal 1/2? Well, we need to get A in its own, calculate our answer. So, and like we're saying here, a wee reminder, it's always positive at this stage. It doesn't matter about the top line, it just identifies the quadrants. So let's go for it. Inverse cosine of 1/2. If we're in degrees in the calculator, it will say to you probably 60, hopefully. Right, let's fire that calculator answer into the two ticked quadrant formulas, 180 minus 60 and 180 plus 60. Okay, and 180 take 60, 120, 180 add 60, 240. Put the wee degree sign in because that's what we're working in there. That looks like we've got our answers there. Okay. The right hand side, once we'd factorised it, u take out 1 equals 0. That means u equals 1. But remember, u is cos x. Okay, u equals cos x equals 1. See, when you get sine or cosine equals 1, -1 or 0, always use the graph. So that's what we're doing here. And putting the graph there, and what we'll call in the blue, the curvy thing, y equals cos x, and the horizontal line up at 1, y equals 1. Where does y equals 1 meet cos x? It just on the tip of it, it's right at the top. Okay. 1 and -1, so that's above 0 and 360. So remember, we always have to come down to the x-axis. We're solving for x. That's what we're doing here. Right, so it looks as if we're meeting at 0 degrees and 360 degrees. Right, that looks like our answers. They look good to me. Again, it's the angle we're looking for here, above, directly above the x-axis, the horizontal axis. Right, okay, that looks fine to me. Well, what they're saying, but in the initial question, what they were saying to you there, they wanted the answer x to lie between 0 degrees and 360, but here it was actually inclusive of 0, see the less than or equal to sign. So that's fine. That was one of our answers. At the other extreme, it was 360. That seemed fine, but that was not inclusive because we don't have a wee equal sign there on that. If we did, then that would be fine. So I just want to point that out to you there. If it was like that there, we could include 360. But the thing is, it doesn't, so we can't. So there we go. There's the two solutions from the graph. We could get them for the coordinates, but it's a wee bit complicated. Right. So 0 is fine. 36, it's no fine because we don't quite get there. So we need to disallow it. And only answer is 0. So for the second part, that's one of our answers. But remember, we actually had two answers in the first stage. We got it for there. Okay, so you can rewind in the video if you didn't quite get that. So it's 120 and 240, and we just got 0 there as well. So why don't we put these together? Okay, so it was our initial equation. That was between the bounds, including 0, not quite reaching 360. So we got 0, 120, 240. And I think that looks good to me. Or is it, Tommy boy? Fuck, it looks good. So that's all our solutions for this one. In this one, you might want to go back and use quadratic formula if you don't know how to solve. Like 2u squared minus u minus 1 equals 0. But that's your job because you've done it before. Okay, so I think I'm going to leave it there. Okay, right, so I'm just going to bring this up here. Are you going to come up here? Okay. Oh, it's no limit. Maximize. Oh, there you go. I always panic at this stage because it means I've not recorded it. I think I have. So I'm going to leave that one there. Okay, folks?